Hi, this is Calculus 12, Chapter 6.3. We're going to be looking at integration by parts. This is the reverse of the product rule, almost. So let's do a quick derivation here. We take the derivative of u times v. We get du dx times v plus u dv dx. We rearrange. And we get u dv equals d dx of uv minus v du dx. And the next step, we integrate. With respect to x, and we simplify. When we simplify this, we get the integral of u dv. When we simplify this, we get uv. And when we simplify this, we get v du. And this is our integration by parts. So let's look at a simple example. Our goal is to find u dv. So we get the left-hand side, and then we substitute uv and v du on the other side. So this is a matter of practice of seeing where the patterns come in. So we say u is equal to x, and we say dv equals sine x dx. So we want something that's easy to take the derivative of, something that's easy to integrate. Du equals dx, and v equals negative cos x. So now we can substitute with our integration by parts formula. So integral of x sine x dx equals uv. And it's convenient to lay out your equations as u dv and duv. So now we have uv. So I'm going to move the negative sign out front, negative x cos x, minus the integral of v du. So that's negative cos x dx. And what we'd like to end up with something that over here, which is easy to integrate. That way we don't have any more steps to do. So negative x cos x plus, and the integral of cos x dx. So it's better to simplify the negative signs before actually integrating. And then we have negative x cos x, and we have plus sine x. And please don't forget your plus c. Next example. So u equals x, du equals dx, dv equals whatever's left over. That'll be negative e to the negative x dx. And the antiderivative of this is e to the negative x. So we have the integral of negative x e to the negative x dx equals uv. So we have x e to the negative x minus the integral of v du. So that's e to the negative x dx. We don't have to do anything with that. We just copy it, x e to the negative x, and minus, and the antiderivative of this is negative e to the negative x. And we have plus c. This should be simplified. So we have x e to the negative x plus e to the negative x plus c. You can leave it like this, or you can factor. If we factor, we get e to the negative x x plus 1, and then plus c. We still have one more step to do. We need to use our limits of integration. So the integral from 0 to 4, negative x e to the negative x dx equals e to the negative x plus 1. We don't need the plus c anymore because we're doing a definite integral and we're going from 0 to 4. So this is e to the negative 4 times 4 plus 1, that's 5. And we have e to the 0 times 0 plus 1, that's 1. And this simplifies to 5 e to the negative 4 minus 1. Okay, let's look at something harder. Sometimes we will have to do integration by parts twice or more. So this one's a medium one. And if you've noticed what I've been doing, whenever there's polynomials or a monomial times trig or an exponential, I always have the monomial as your u. And it's no different in this case. U equals x squared. dv equals e to the x dx. du equals 2x dx. And v equals e to the x. So we have the integral of x squared e to the x dx equals uv, so x squared e to the x, minus the integral of v du. So that's 2x e to the x dx. Again, we don't do anything with the first term, e to the x, minus, now we have a new u. That's going to be 2x du equals 2 dx. dv equals e to the x dx. v equals e to the x. Put brackets around here. That way you don't mess up your negative signs. So we have uv, 2x e to the x. Always put your polynomials before your exponentials or trigs. Minus integral. And now we have v du. So 2 e to the x dx. And bracket. Now we have x squared e to the x minus 2x e to the x plus integral of 2 e to the x dx. This is simple to integrate, so we'll just do that. And that's just 2 e to the x. And don't forget your plus c. Again, we can factor out an e to the x if you like. That leaves us with x squared minus 2x plus 2 plus c. Okay, here is a hard integration by parts. This is when we have trig and an exponential. There's no polynomials in this one. And it doesn't matter which one you make u, but whichever one you start with, you have to stick with. So if you're making trig u, you have to stick with trig for the remaining u's. Otherwise, you'll be undoing your work. U equals sine x. du equals cos x dx. dv equals e to the x dx. And v equals e to the x. I prefer to keep trig as u because I remember the derivatives. I'm more likely to make a mistake if I'm trying to integrate trig. So the integral of e to the x sine x dx equals uv. We want to write the exponential before the trig, e to the x sine x minus integral v du. So we're going to write the trig first, e to the x cos x dx. So looking at this example, we can see why we learn differentiation before integration. Integration by parts requires us to do derivatives and integration in the same problem. Okay, now we need a new u. U equals cos x dv still equals e to the x dx. Du equals negative sine x dx. And v equals e to the x. So we get e to the x sine x minus bracket uv, that's e to the x cos x, minus integral v du, so minus e to the x sine x dx, and bracket. Okay, let's clean up the negative signs. We have e to the x sine x minus e to the x cos x. And we have 1, 2, 3 negative signs, so we have negative e to the x sine x dx. So in this problem, we only need to do 2 iterations of integration by parts, because now we have the same as what we started with. Same as I, our initial integral. So think we have I equals something minus I. So really we have 2I equals our something. And then I will just equal that something divided by 2. Okay, it's not always 2. This could be 4I or some other coefficient. It just happens to be 2 in this example. So now we have 2I equals e to the x, and I'm going to factor e to the x out, sine x minus cos x. So I equals e to the x over 2 sine x minus cos x, and plus c. And we should have plus c over here as well.
This is important.
Okay, so in general, the monomials should be u, and the exponentials and trigonometrics should be dv. And you can use this last example as a template when you're dealing with exponential and trigonometric. And that completes this lesson.